I was kind of thinking about how I would keep my audience alert for 40 minutes. And I've decided to go with an approach where I would be quite subjective, and I would try to introduce some clickbait heading into my talk to kind of really keep your blood pressure up. I also have a clip of a ninja movie in the midst of all of this, so you do want to stick around. I've spent quite a few years in academia, and even a few years quite recently. And this time I decided to not be very academic. I've decided to really summarize what I have seen work and not work for development teams. And the trigger warning, I guess, is that this is like super subjective. I'm trying to, for every slide and for every situation I will be talking about, I've tried to kind of make an observation, link it to successful or not so successful behavior, and then kind of offer my interpretation. So I don't want you to kind of enter this talk thinking that these are instructions, these work everywhere. They don't, but this is kind of how I see the world. And obviously, I have not been to all companies. I haven't seen everything. So this is kind of subjective. So just to kick you off, this is what I will be talking about. So you see my schedule full of clickbait all over the place, but I'm going to try to argue for and against these practices. So while this is the technical track, I will be talking about practices on a meta level. So I think I'm going to be showing one snippet of code. So let's start with the don'ts. And the perspective is successful development teams, because we kind of want to copy success, right? So I don't really perceive successful software development teams doing agile. And what do I mean by that? I think there are two ways of doing agile. One would be this. This is something I've made up, to be fair, but I'm quite sure that I could find this on someone's blog if I really looked for 5 minutes. This is one way of doing agile, I guess, and I think it's a very costly way of doing it. And the teams that I have seen that have produced stuff, that have had good results, that have been like simply good teams, have adhered to a different agile mindset. And that mindset is this mindset. So as you see, there are like two competing models here. And I think this could be talk in itself, but this is just my observation that the really, really good teams have not been walking around talking all the jargon, all the terminology that you can easily throw into the mix. They've been kind of working, delivering, getting feedback. On a related topic, I have not seen, let's say, capital D DevOps work either. So let's say you're a team that's having some difficulties starting up, so to say. You have a code base that you're not really confident in, and you don't really know what to do, and there's a pressure to deliver. What I haven't seen work is bringing on board like 2 or 3 capital D DevOps people with the entire technology stack. Like, let's say you've got like this Amazon guy who sets up Kubernetes in Amazon, and you've got something else. You've got some Prometheus here and there and stuff like that. And somehow these two realities have to merge. I have not seen a successful merger of capital D DevOps. What I have seen is that such teams tend to sit isolated in a corner somehow, somewhere. They keep themselves occupied with their own stuff, so to say. and they have the, let's say, I don't know whether I would call this luxury, but they are not really related to, their work is not related to actual customer delivery. So they've got some kind of carte blanche working on their stuff, and somewhere these two realities need to meet, and I have not seen a successful merger of these two realities. What I have seen is, oh sorry, I did a little goofed up with the slide here. What I did have seen is that teams need to gain some confidence in the release process. They need to be faster, they need to be quicker. And where they start out, it's like an internal thing. They start out internally saying, okay, so we need to increase our release frequency. We don't want to sit all day writing Linux or Unix commands. What can we do about it? And they will stepwise, in by taking teeny tiny steps, they will evolve into what we would call DevOps. But it's really developers doing operations. It's not an external party coming with an entire tool chain. I have heard of it, this work, but I haven't seen it myself. So let's just say it doesn't work in the context of this talk. Likewise, I don't think this kind of capital T testing works. I've spent quite a few years in the testing community, and it's been like a really big issue where you had the entire like profession of testers more or less clashing with an agile team setup, and I think it took a decade to kind of sort out what agile testing looks like, how that supports testing. So by the same token, capital T testing, independent testing doesn't work. Or I shouldn't say, I should be careful and say, I have not seen successful development teams do it. I need to be careful with my phrasing. Many of us have heard of the T competence, or like pie. People should be T-shaped, or people should be pie-shaped. By the way, WOW stands for way of work, not World of Warcraft. So I've just taken like a typical, let's call it a typical competence profile for somebody who would be on an agile team. And I have not seen this work either. By the way, because there is like a theoretical model saying, and I think quite a few people are kind of teaching this, is that the agile team consists of 1 or 2 developers, 1 or 2 testers, maybe some UI guy, somebody doing a database, somebody doing ops or typing in your Linux commands or whatever, and together they deliver on the sprint goal. And to be honest, I haven't seen that work, because this is basically, and trigger warning here, but in my mind, this is just a bunch of one-to-one dependencies. You get a mix of like a track factor of 1. If the database guy goes, then you've got a problem. If the UI guy goes, you've got another problem, so to say. And obviously, work isn't distributed like this in an iteration. It's not like you've got 80 hours of database work, 80 hours of testing. So okay, so here comes the generalist part. So you're supposed to be like a generalist and be able to cope with all domains, and that's fine, I guess. But what this T and pie shape thing doesn't really say is, what does it mean? What kind of competency profile would you have in the areas where you're not a specialist? What I have seen work is actually doing the reverse of this. If you shape your competency profile as the inverse of a pie or the inverse of a T, then you're rolling. And I think this would be my personal greatest tips to anyone who is in charge, has a leadership role, or shapes a team, is to really try to increase everyone's competencies in all areas. not stick to these stereotypical T's and Pi's. It's just my personal advice. Okay, this one is simple, right? I took an ad. I think it's still Googleable, this ad actually. Ninja is, by the way, one of the most hated jargon words out there. But my experience is that I have not seen teams that were full of ninjas and gurus. Why? So my definitions of ninjas and gurus are like this. So a guru is the guy, it's in 95% of the case, it is a guy who wrote the system. That's the father of the system. That's the go-to guy. The go-to guy defends the system. The go-to guys should have changed jobs because the go-to guy is kind of tired of defending his system. A ninja is, I will show you what a ninja is, and it's the best clip of development doing software development done by ninjas. I'll show you what ninja is, but I think the alarming thing about ninjas is maybe not the kind of development, software development the ninja would do, but the kind of signaling of detachment between HR or management or whoever does the hiring and the software team. Because you probably, if you are a gelled team, you probably don't want a ninja. You probably want another team member who will contribute. And let's see if I cannot share my screen because I've got a big screen. So let's see if I can just quickly share another screen. So this is what a ninja does.
Not sure if there's supposed to be audio, but we're missing audio.
That's okay. I think you get the picture anyway. So, did you get the audio or not?
I don't think anyone got audio. I didn't.
Don't worry. It does add. There's dramatic music, and he's shouting, and you hear the flames crackle. But I think the visuals kind of speak for themselves too. So let's just sacrifice it. Let's sacrifice that one. I'm still happy to have made the transition. So my point is that, again, I have not seen successful development teams running with members who behave like this. And you know, when he was kicking the running people there, that would, for example, be the testers, right? He wants his code out, and the tester says no, and they start running, he scares them. You get the picture. So my point is that successful development teams don't adhere to this practice. Here's a nice one to get your pulse going. Successful development teams don't branch. And this is, I have to admit, this is a little of a clickbait here. But let's just talk about branching. So if you see my little slider at the bottom of the screen, imagine how you actually go about branching. Let's say that you were forced to have a branch that lasted for, let's say, in the order of magnitude of seconds, let's say 30 seconds. During this window, you would be able to have your IDE rename a method. You would be able to delete a method. And then you would have to commit and push, or whatever your version control systems call it. But that's what you can do in a few seconds. If you've got a few minutes, you can write a single unit test. You can add a simple method. You can do some more complex refactoring. If you've got a new few hours, you can add a new feature or part thereof. And yeah, what many of us see and still experience is feature branches. Feature branches, which are like the default thing to do is to have a feature branch. And if you're really advanced, because Git is very good at it, you can branch off a feature branch of a feature branch. You can do that too. I'm not going to kind of repeat the obvious things about merging with or without Git, what that does to your CI and these things. But what you lose, and there is one very important thing, what you lose with these long-lived branches in the magnitude of days or even weeks if you're unlucky, you lose a certain way of programming. You lose the way and security of programming by tiny increments. And I think this is an extremely valuable skill to program by adding like a little refactoring, adding a method, changing something, always remaining at green. And my point here is that if you shrink your time, horizon, you actually go from these short-lived branches to trunk-only development. And my point here is that I'm not saying that all successful software teams that I have seen have done trunk-only development. They do branch, but they do it as an option. They know how to do trunk-only development. They know how to work with tiny increments. They know how to kind of keep the trunk green always, and then they choose to branch for whatever reason. And that's the clickbait part here. So yes, they do branch, but they branch for the right reason and not just because everything you do is supposed to be a feature branch. The same goes for pull requests. And I just have to say, I do have issues with pull requests, really. And that's like a personal bias. I'm telling you my bias here. I really have issues with pull requests. So when are pull requests good? Well, obviously, if you're running an open source project, of course you want pull requests. How else would you do it? Well, it's been done previously in the past, but anyway, that's a good thing. Of course, if you're distributed, if you want to add to another team's code base, fantastic. Or if you're training people, if you've got junior developers who want like a written feedback, isolated written feedback, it's a fantastic tool. And all of these are great benefits of pull requests, but there are some downsides. And one downside is, again, just my observation is that they tend to strangle out, pull requests tend to strangle out other practices that you would use, other complementary practices. And I will obviously tell you what those practices are. They also, of course, increase, like they introduce artificial delays and increase the level of multitasking, because you kind of have to wait for people to approve them, look them over, and somebody has to interrupt something to look at a pull request. So there's delay in multitasking. And if you're very unlucky, this entire thing is actually like an evil mastermind plan by this one person who needs to stay control of the entire team for the wrong reason. So these are the downsides. And my argument is that there are some alternatives to pull requests. And they're quite a lot about communicating, because like a pull request is an after the fact thing. So obviously, if you like talk to each other, you do pair programming, you do structured code reviews, you have a standard. I mean, oftentimes when you do a comment on a pull request, you're not really gonna catch a bug because you're stressed with your own pull request. You're gonna comment like, you haven't spelled this properly, or you're not adhering to our standard, this and this, and that would be the coding standard part. Testing is a fantastic, also a fantastic complement, but the kicker is talking to each other. My point here is that the teams that I have seen really succeed, they use pull requests, but they use it as a tool among the other practices, among the things that I have listed as alternatives. It's not something that's built into their pipeline, that's mandatory, that's stopping them for like an automated way of stopping you. It's more like it's a technique. They have a toolbox full of techniques, and this is one of their techniques. So they do use pull requests, but they know why they're using it. Them, not because of a tool says something. And there's one more thing that they do, successful teams don't do, and it's program with strings and ints. And this is, I think I'm stealing this concept, this line of our argumentation. I think I'm stealing it a little from Kevlin Henney, I think, but I'm making it my own because I've seen it so many times, so I can easily make it my own. When you enter a team, it's not unheard of that you see code, that you basically see procedural code wrapped in big classes. They don't need to be 3,000 lines of code. They can be 300, they can be 500 lines of code. Line count doesn't really matter, but it's like procedural code. And code stays procedural if you program with primitive types. If your domain is that of strings and ints, you're going to get procedural code. And it doesn't really matter that you call something a class, and it's not going to matter that a class is going to call a class. As long as the atomic components of that are strings, ints, and sometimes floats, maybe lists of strings, you're going to be screwed anyway. A typical architecture, and this is old. I mean, it even dates back to Corba, Corba, Java, RMI. These days it's called JSON, but it's the same thing. You've got something, you've got a carrier of strings and ints and JSON object, often these times, which goes into some kind of facade, which is some kind of service, and that kind of mangles this thing around and produces something else that carries strings and ints to another layer, and finally you persist it. Many systems are written like this. And it's very hard to be a successful software team if you have a system written like this. Now, this is a topic for in its own, but I'm going to try to make a complicated topic, cram it into a slide. The alternative to this is obviously to have a rich domain model, and we can even call it like, don't have a rich domain model, like do object-oriented programming. That's what you need to do. So I've taken this like super generic thing that everybody can relate to. You've got the user thing. A user has a username, a date of birth, and an address. Now, my point here is that if you make everything in here an object, like a date of birth, and we can argue whether you should have a date of birth or something, or age or something, that doesn't really matter. But the point is that there are rules governing a date of birth. It's a positive integer, it's got some kind of interval, it's probably not going to be 10, right? So there are rules governing this. There are rules governing a username. A username needs to have a certain length, it has to adhere to a certain format, may or may not contain certain characters, whatever. Swedish addresses, there's tons of rules about what constitutes a valid Swedish address. And you can keep going like this. The point is, if you push, and these things, if you are in this old world here, these things are usually going to be strings in these JSON or RMI or whatever just the POJOs, whatever you choose to send here, they're going to be strings and the ints. And if you really shift towards having a rich domain model, you're going to redistribute your code. You're going to go from this procedural code to have code distributed in tiny objects, and this has so many benefits. Obviously, it makes everything more testable because you get rid of this big procedural code, but it also makes the code more secure, and it also inspires confidence, because if you know that I have an object that I trust, and that's like programming. It's almost like programming by contract. I've got an object that I trust to be a date of birth or to be a valid address or something. I never have to write a single if statement on that object because I'm so confident in its properties. And it also happens, and I wish I had Frederick's beautiful slide because this is stolen from Wikipedia, but it also happens that if you've got this model here, it's going to sit at the core of a hexagonal architecture. This rich domain model is going to sit at the very core, and then you're going to have these services here, and you're going to have your ports and adapters all around it. But everything is going to happen in the model, and this model will be super, super stable. Thank you for nodding. So it's super important. And my point here is that, again, where were we? Successful software teams don't program with strings and ints, they have rich domain models. Okay, moving on. So now I've switched gears and I'm talking about what successful teams actually do. And the first thing they do is that they do not write code. It's so easy to get trapped into thinking that every single problem is a software problem, and it's not. Successful software teams are very good at negotiating. Is this feature required? Is this complexity of this feature required? Can we hire 20 students to do this manually? Would that make sense? Wouldn't that be cheaper than having 5 developers spending X hours doing it? I think it's really in its place to quote the Agile Manifesto here, and the principles, by the way, the principles are much cooler than the 4 pillars. But successful software teams are great at not writing code. And if they choose to write code, they're going to throw an equal amount of code away. So at least they're trying to keep code constant. So 1 in, 1 out. This one is kind of obvious. I don't need to. I shouldn't need to have this slide because this one is obvious. I hope this doesn't apply anymore. Like if your code works, don't touch it. And of course, there is, to be fair, there are exceptions to the rule. You've got your mobile game, which is gonna be out on the market for half a year, and then you can't reuse it, of course. But in the majority of cases, this is not where you are, and you're gonna be touching code. And here I'm gonna think loud because I'm. I'm going to be thinking loud here about why you should touch code. So if you've got your code written in the past, oh no, let's do storytelling instead of just looking at the slide. I have a colleague who just the other day, I was looking at his code and I was giving him some feedback. And he said, but that's legacy code. And I said, well, this code was written 2 months ago. That has to be some kind of record for legacy code. I mean, legacy code is the scary thing that's written 10 years ago. Everybody who's written it have left the organization. It's the big code without unit tests. That's how you would traditionally define legacy. However, let's try it different. And this is me thinking here. Let's try a different definition of legacy. Between what, this is, by the way, a fantastic person who has learned so much, is making fantastic progress. And between the code that's been written here 2 months ago, the system has evolved. I mean, new components have been added, the code has been added, removed, the architecture has changed somewhere, conventions have changed. We have learned as a team about the language. Like people learn more about the system, people learn more about the language. As time passes, you get to know more about the users and their actual needs. So there is like learning going on, going on. And it actually, even if you froze all of these, like if the system didn't change, you didn't learn anything about the language, the users wouldn't come up with any new requests or have any new needs, there would still be you developing as a person and the team. Let's say you are a software team that hates doing regular expressions. Whenever you do a regular expression, you failed. And that it's just, you can either, of course, learn to do regular expressions, but you can say, okay, we are the team that doesn't do regular expressions. And you have kind of learned something about yourself and the team. And while you're doing this, all of this learning, the world is changing, like new versions of stuff are coming out, you absorb new information. So even if you kind of freeze your organization, like your team, you'll be able to freeze reality, reality is going to change around you. And as these things increase, as time passes by here and these deltas increase, they create a tension. And I think, and this is, I really haven't finished this thought, but maybe legacy code is code that, if this tension becomes too large between what you would have done today and what you would have because of these deltas, that would be legacy code, not 10-year-old code without unit tests. Maybe it's 2-month-old code with unit tests, but where these things have increased more than you're comfortable with. I don't know. It's an open thought. I'm launching it here today. But anyway, the point is, rewrite code that works. Have it fit your mental model. And obviously, if this is like super legacy, you're not going to be able to hire anyone to work with on it anyway. So you have to, but it's like a side topic. Successful development teams write their code twice. Not all of it, obviously. This is my daughter. I asked my daughter to draw sheep and draw a person with a stick. Unfortunately, she drew a person with a machete or a sword, and yeah. But the thing is this: how do successful teams cope with junior developers? Junior developers need to learn. Junior developers need to train. Junior developers will make mistakes, and maybe not in terms of bugs as such, but they may design something in a funky way, or not stick to some idiom or something. And how would you use junior developers in a good way? And you could, of course, pull request them to death, right? You could do that, or you could actually let them. Yeah, thank you. You could let them roam free a little, and make use of agile software development, because and I'm sorry about this picture, really, it's just a picture, like, don't get it. I did have a trigger warning at the end, at the beginning of the session. But anyway, you could let them write their code, and you could use like the stamina and the energy to actually get a delivery. And you could actually use this feedback, because this will actually, I mean, if you start doing pull requests here, you're not going to deliver anything. But instead, have them deliver stuff, like let the team deliver stuff, which is not perfect. But you will get your feedback from the users. You do have a delivery, you have something out, users will see it, maybe you will have a bug, I don't know. But then, at least people will learn from real experience. And then you've got the senior walking afterwards, cleaning stuff up instead of pulling or request people to death. I've seen this practice on a few teams. Not statistically significant, but I think it's a good one and it's a successful one. Successful teams write novels, not code, and this is like a simple one. And this is like a true difference between junior and senior developers. So if you're just starting out, this is like let's say 0 to 5 years of experience. You're very happy to make stuff works on your work on your machine. If code works on your machine, you're like, yes, I did it. It probably doesn't look that good, but it works. You even write some unit tests and it works. If you've got a few years under your belt, you're gonna kind of know about patterns, you're gonna know about language idioms, you have seen a few variations, you're gonna know about architecture, and you're gonna start writing things for not only the machine. You're gonna start writing it for other people as well. And obviously, if you've been in the industry for a while, I mean, I've seen people write code that reads like a book. You can literally give it to a non-technical person and says, what does this code do? This is again a big topic, but like a shortcut to getting to here would be like use the language properly. There's much to be known a programming language. Use the patterns correctly. And I think the most important one, which really gets beginners, is programming at a different level of abstraction. This is my only code snippet, and I use it in my clean code talk as an example of not clean code. And this is what I mean by programming at different levels of abstraction. So you've got your whatever account service. So you say, okay, I want accounts for user. Okay, swell, you've got account service, you've got accounts for users. You have some kind of account identifier. Okay, that could still be in your actual domain. And then everything goes to poo, because then you start programming with strings and ints, and you're out. You're lost. You're dead there. So, and if you're a successful team, you avoid doing this. You do not have code like this. Moving on, time flies when you're having fun. 10 years ago, we started a trend saying that we don't need documentation. We just need to snap a picture of our whiteboard. Let's photograph our stickies. What a fantastic idea! It's going to be searchable. It's going to be easy to find. Not. This, ironically, this particular picture is the outcome of my best architectural workshop ever. This is super, super good, but it still looks like crap. I mean, really, you can't do anything with this. This is an actual, like, the team has been working for 2 hours, producing superbly facilitated, superb result. Still, it looks like crap. My point here is that good teams are actually doing lots of writing. Successful teams do not cheat on documentations. They will add the meat to their user stories, because after the card conversation and confirmation, you actually add the meat, right? They do have a software architecture descriptions. They do write the API comments. They do keep notes of their meetings. Bug reports sound scary, but they document somehow. There's bug documentations. They will, well, they're just gonna document stuff. I have and this is this observation interpretation. It's just me seeing, okay, good teams write stuff down. Successful teams work under pressure. Pressure is a negative word, but successful teams have like a huge backlog. They've got a huge backlog, and they know that they're working towards actual needs. So they've got an effective product management, or they know their users, and they know that we need to implement all these features. It's not sales-driven development. They know that their features are relevant. They have the autonomy to kind of attack this backlog in any way they please. And they have the self-efficacy to do it. And because they're actually producing lots and lots of stuff based on this backlog, they get the feedback and they got the self-enforcing loop here. But the point here is that this is a funnel, and this funnel is big. So successful software teams do not muck around with the point is that they are working under a tight schedule. And to conclude the talk, I want to conclude the talk by talking about how successful software teams are becoming agile. So I told you that they're not doing agile, but how they are becoming agile. And that was the cliffhanger of the talk. And you know, if you're a team that starts out, you've got, and you're supposed to be agile, and you're supposed to do all these successful software practices, how would you go about it? And my biggest tip here, and this is like the common thing, like common across all these topics that I've addressed in this talk, the common thing is like go for a cadenced delivery. Set a cadence, 1, 2, 3 weeks, deliver something. If you want to become a successful software team, aim for a cadenced delivery. And if you know that you want to hit a delivery every second week, every third week, you will have no trouble whatsoever identifying the next thing that you need to improve. What would you focus on? You're not going to be focusing on a random activity. You're going to be seeing, we need end-to-end tests at this stage because, or we have a trouble deploying our code, or maybe we can't even get proper wishes from our users. So go for a cadence delivery. That's what the successful software teams that I have seen have done. Thank you.